Hello, my name is Arnesh. The school I go to is Irvington High School, and I'm going to go to 12th grade after the summer. So the project I chose was a gesture-controlled car with accelerometer, and this is my final milestone, where I was able to make the robot move according to the position of the accelerometer. So to demonstrate, here's my robot. So if you see this robot, and here I have my robot, which has the H bridge, which is connected to Arduino Uno, which is connected to the breadboard, which has the first Bluetooth module. And here my accelerometer, which is connected to the other breadboard, which has both the Arduino Micro and the other Bluetooth module. So to make it work, now I have to turn this battery switch on, but I'm actually going to keep it off the desk because if I keep the wheel spinning on the desk, it could be dangerous. So let me hold this robot off the desk. Let me turn this battery switch to on. So here we see the motors are spinning. But how do I make these wheels spinning in different directions? So here I have my accelerometer. So if I make this accelerometer turn forward, so if I turn this forward, you see the wheels are turning in one direction. If I spin it in the opposite direction, which means backward, the wheels are gonna spin in the opposite direction. The same thing applies for left and right. So if I turn this accelerometer left, then the robot should turn left. If I make this accelerometer turn right, then the robot should turn right. So if I keep switching position, you can see the wheels are gonna act accordingly. And that's how I was able to how I was able to get this project to work in the end. The main part that is left, however, is to get the robot actually on the ground. But let me actually turn this off because we don't want these motors to be running right now. And the first problem, or the first part of this milestone was getting the motors to work. The main problem I had to summarize was that the black battery wire from the battery switch was the metal part of the black battery wire was small. So in order to fix that, I had to strip the wire, and I'm actually new to stripping the wire, so it was a new experience for me. And I basically learned how to strip the wire. It took some time for me to get used to it, but after working several times, I was able to strip the battery wire off. But to actually strengthen the electrical connections, I had to actually solder the metal part of the black battery wire. So after soldering, I was able to make it stable in the H bridge, and that's how I got the motors to work. So depending on this program, this program is basically to test if the motors actually worked or not. And I could actually change this high. I could actually change this high low, but when I change the high low, it's going to change the direction in which the motor should be spinning. So if I wanted to turn in this direction, if I wanted to turn in that direction, I would basically use this program to test in which direction I should want the motors to turn in. But the main part comes to the next part was determining the gestures. So the main problem I had to come across as part of this was determining, depending on the position of the accelerometer, which gesture should it read as. So if I turn it forward, the gesture in this case should be forward. If I turn it backward, it should be backward. So I had to spend some time figuring out how to determine the gesture. It wasn't actually, it took a while, but I had to figure it out. So if using the test cases, using the sensor test, I could actually determine the X, Y, Z. And depending on that, I could actually use these conditions to check if I was making this accelerometer turn forward. And if it is that case, then I'm going to serial one write F. F means forward. So here, these letters represent the gestures. F means forward, B means backward, L means left, R means right, and S means stop in place. So I have to use a bunch of these conditions to check, depending on the position of the accelerometer I'm holding it in, which gesture should I write to serial 1? Serial 1 is basically what I use for hardware serial, which is what I use for Arduino Micro. And in fact, my accelerometer is connected to my Arduino Micro, which also has the Bluetooth module. So here's my first Bluetooth module, as you see. The main part is, however, transmitting the data from this Bluetooth module to this other Bluetooth module. So what I mean by transmitting the Bluetooth module, which is connected to my accelerometer and Arduino Micro, and transmitting that data somehow to my other Bluetooth module, which is connected to my Arduino Uno, the whole robot, and the H bridge. So that's where I had to make this program which actually reads that data. So the main part I had to figure out is how can I actually read that data. So the main part comes through if config BT available, which means if the Bluetooth data is actually available, then I'm going to create a variable called C, store a value of config BT.read, which is basically the character representing the gesture. So it could either be F, B, L, or S. And depending on those characters, I had to use the different cases. So if it was forward case, which means F, I had to call a function called forward. Same thing for the other cases. So if it was L, calls the function call left, R means right, B means back, and lastly, S means freeze in place. So I had to create multiple of these functions. The purpose of these functions was to determine which direction I want the motors to turn in. So if I wanted motors to turn forward, I would make it turn in one direction. Backward means I had to make each of those motors turn in the opposite direction. And freeze means the motors shouldn't be moving. Left and right, I also had to figure that out too. So I basically used this program to test each of these. So digital right, this is basically my test program to determine if it was turning left, if it was turning right, forward, backward, and stopping in place. And after figuring that out, I was actually able to get this robot working, depending on the position of the accelerometer. So I have to now put this on the ground, and I should now be able to make this depending on the position of the accelerometer. So if I move it forward, then my robot should act accordingly. And I'm really glad that this worked out in the end. I would describe this, I feel really happy that this worked. We spent a lot of time, especially on the Bluetooth modules, and now I'm really glad that this worked. So the main part that's left is getting the robot on the ground, but that was basically my final milestone.